10 alternatives to the Big Bang Theory. Number 10. Quasi-steady state. In the beginning, there were two theories. The Big Bang Theory stated that the universe began with the singularity, a point at which everything was infinitely concentrated and time didn't yet exist. Opposing it, the steady-state model said that the universe never began because it has always been here. Over time and with new evidence, the Big Bang emerged victorious because radiation found in 1964 was discovered to be a relic of a massive expansion, which pointed to a universe that had a beginning. But some people just couldn't let go of the disproved steady-state model, and in 1993 it was updated. It became the quasi-steady-state model instead. This theory says that as the universe expands, little pockets of matter are spontaneously created throughout the universe, called little bangs. This keeps the density of the universe constant, meaning that the universe could have been expanding stably forever. However, it still fails to deal with the radiation that was discovered. Number 9. Eternal inflation. For a split second after the birth of the universe, it expanded at an incredibly intense rate. This intense inflationary energy was then converted into matter and radiation. After this, the growth or inflation of the universe slowed substantially. At least that's according to the Big Bang Theory. However, proponents of the eternal inflation theory, like physicist Alan Guth, claim that the intense period of expansion didn't need to stop all at once. He theorized that our universe was just one small pocket of a much, much larger universe. The much larger universe is expanding incredibly quickly, while our universe is a small bubble within it that slowed down. The implication of this theory is that there are many other slowly expanding bubble universes emerging in the greater universe. Number 8. Mirrored universe. In 2014, Julian Barber at the University of Oxford modeled a system of particles under gravity. When the particles expanded outwards, he found that they did so in two different directions of time. Barber likened his particle model to a replica of our universe, coming to the conclusion that the expansion of the Big Bang should have created two universes, moving in two different directions in time. Essentially, on the other side of our Big Bang is a mirror universe, moving in the opposite direction in time. But unfortunately for time travel fans, the theory states that if you were in the mirror universe, you would still feel as if time were going forwards. Number 7. Colliding in higher dimensions. Princeton string theorist Paul Steinhardt has come up with his own idea that explains the Big Bang. In string theory, there are more spatial dimensions than we can see day to day in our three-dimensional world. Steinhardt argues that our 3D universe can be imagined as an object moving through a higher dimension that is invisible to us, and there could be other 3D universes doing the same thing. So, if two 3D universes were to collide and stick together in this higher dimension, they would create something that looked like the Big Bang within the 3D universes themselves. The energy of the higher dimensional collision becomes the searing temperature that we see at the beginning of our universe. Number 6. Gravity's rainbow. The rainbow gravity theory states that light experiences gravity to a different degree based on its wavelength, and therefore its color. In this system, for example, red light would feel gravity more strongly than blue light due to its longer wavelength. The effect is usually very weak, but extreme objects like supermassive black holes should be able to demonstrate it. As you approach the beginning of the universe, rainbow gravity becomes more important due to the universe's more extreme state. When this has been modeled, scientists find that the Big Bang's singularity can disappear, and in fact there are instances in which the Big Bang doesn't even occur in the simulations, with time stretching back forever. This suggests that the universe has always existed. Number 5. The slow freeze. In the standard model, the Big Bang is super hot and expands quickly, but Christoph Wetterich claims that the universe was actually cold and evolving slowly. He thinks that the past just appears hotter to us, rather than actually being hotter. To get to this picture, he asserts that gravity weakens with time, while particles get heavier. Today, this would make the early universe look hotter than it in fact was. In this theory, the universe has always existed in a state of deep freeze, before it began to thaw around the time of the Big Bang. Unfortunately, Veterick's idea is impossible to prove, as we're unable to measure whether all particles in the universe are getting heavier, as there is nothing to use as a benchmark that wouldn't change itself. Scientists have been critical of his model, saying it's like arguing a ruler is getting shorter rather than the line it's measuring getting longer. Number 4. Digital simulation. Imagine that humans don't go extinct, and instead we advance to a super civilization with unimaginably impressive computing power. We then decide to run a simulation of the universe to better understand it. In fact, we create many simulations, varying the initial conditions slightly in each one. Nick Bostrom argued in 2003 that in such a scenario, we are almost certain to be in a simulated universe. This is because the amount of simulated universes would outnumber the one real universe by such a staggering amount that the probability that we are living in the unadulterated universe classic is as good as zero. In this theory, which has gained many supporters including Elon Musk, the universe may have started with a Big Bang, but that Big Bang was started with the tapping of an enter key. Number 3. Quantum graviton fluid. After making a few tweaks to Einstein's theory of general relativity using quantum mechanics, scientists have suggested that the Big Bang theory might not be correct. These quantum adjustments essentially remove the Big Bang's singularity, the point where the universe was infinitely dense and hot. This model has suggested that the universe is infinitely old and full of quantum fluid. This fluid is literally everywhere and is made up of tiny particles called gravitons that mediate gravity. We just haven't detected them yet. These new equations also deal with mysterious dark energy, which currently accounts for 68% of the energy in the observable universe, even though we have no idea what it is. According to this theory, dark energy arises naturally from the quantum adjustments. However, there is still a lot of work to prove that this model is an accurate description of reality. Number 2. Dimensional ripping. There is a pair of superstring theorists who believe that the universe has 9 dimensions of space and 1 dimension of time, and they think they have found an alternative explanation to the Big Bang. By using a supercomputer to simulate a 9-dimensional universe, Sang-Woo Kim and Jun Nishimura have discovered that, after a given time, a fluctuation will occur and 3 dimensions will break off and rapidly unwrap. Those 3 dimensions are the ones we know and love, and this dimensional disentanglement is supposedly the creation of our universe. After these 3 dimensions broke off in the model, the physicists saw a similar Big Bang and rapid inflation characteristic of our own universe. What happened to the other 6 dimensions? Well, apparently they are so small as to be unnoticeable. Pretty convenient. Number 1. Cyclic universes. Roger Penrose is a giant of the physics world, and recently he proposed his own earth-shattering cosmological theory. Titled Conformal Cyclic Cosmology, it neatly expresses a very attractive theory that you yourself may have thought of. The universe repeats in a cycle with each new Big Bang. Penrose says that the state of the end of our universe, which stretches off into infinity, is in many ways mathematically identical to the singularity at the Big Bang. He says that this mathematical resemblance is not just a concept, but also a reality. So, at the end of each universe, a new one begins. What's more, Penrose thinks he can detect the echo of a collision of supermassive black holes from the most recent previous universe. So he may actually be proven correct in time.
Hey guys, if you enjoyed this video, then check out 10 unanswered questions about the universe. There's some proper mind-blowing stuff in there. Be sure to check it out, and we'll see you next time. Cheers.